Hello students, good day all. The continuation of thermal properties of matter. In this session, we are going to learn about the thermal expansion, that is the thermal explanation part of the thermal expansion, practical application of the thermal expansion and the anomalous of the water. These are all we are going to explain through the graphical representation, and we are going to learn the specific heat also. Let us see students, this is a molecular explanation of the thermal expansion. See the graph students. So this is the relation between the potential energy and this is of two neighboring atoms in a crystalline solid and their interatomic separation, which is you are seeing the graph nature is the parabola, right? So asymmetric of parabola we can say. So you may observe that the temperature which is there T0 is 0 Kelvin. At that time the atoms remains the equilibrium separation of R0 and their oscillation energy E, which is minimum. Yes, it is reaching minimum. See children, the end point E0 at T0 degree. So which 0 degree Kelvin means the atom remains equilibrium separation. And at its E0 value is, the energy value is 0, right, minimum. We cannot say 0, that is minimum value. As the temperature is getting increases, what is happening to the energy? See, the energy of the atom will also increases. So that it is starts vibrating about their equilibrium position with the interatomic separation of the oscillating between its minimum and the maximum value, right? So the average interatomic separation between the value we can say R which is equal to R minimum, right? R which is equal to R minimum plus R maximum by 2. So this is the interatomic molecular value. We can say that is the separation of the average interatomic separation. And the temperature if suppose increases, what will happen to that amplitude of the variation of atom will also is increasing, right? So that you may seeing the curve, that is the average interatomic separation is increasing. So that the consequence of this increase in the average interatomic separation with the temperature, that solid will get expand. When it is getting heated, it will get expand, right? So the practical application of the thermal expansion, one by one we'll see. See the first one, a small gap which is left between the iron rails of railway tracks. See, we can say that two rails are joined by fish plates. Actually, you may notice that if no gap is left between the rails and the railway, that is rails may bend due to the expansion in summer and the train may get drilled. So the next one is the space is left between the grinders which was used for supporting the bridges. This allows their expansion actually during the summer. Moreover, we can say the ends of the grinders are placed on metal rollers to allow the expansion and the contraction to take place easily, the change while the seasonal change. So these and all it's happening due to become of the seasonal change. Right, the next one is a glass stopper jammed in the neck of a glass that can be removed by warming the neck of the bottle, right? So when the neck of the bottle is slightly warmed, then what will happen? The mouth will become slightly wider, so that the stopper becomes loose and then it come out easily. So these are all some of the examples which we are seeing for the thermal application, the practical application of the thermal expansions, right? So the next one is the anomalous expansion of water. Actually, we can say all the liquids, it has the peculiar manner of behaves when it is heated, right? When it is all the liquids, it's suppose expanding, it has the unique manner. Like we can take that is the water at 4 degrees Celsius, it will get the maximum density, right? Now, you may see by observing the diagram, that is the graphical representation which we seeing on the screen, that is the thermal expansion of water. And you may see the variation of the density of water with the temperature. Now, when the water is at 0 degrees Celsius, when it is heated, its volume actually decreases so that the density is getting increases until its temperature reaches 4 degrees Celsius. Above 4 degrees Celsius, the volume increases and therefore the density decreases. Right. By that way, we can say that the water at 4 degrees Celsius, it has the maximum density. Right. The practical importance of the anomalous expansion of water, as we already explained that the water at 4 degrees Celsius has the maximum density, right? So the anomalous expansion of the water, it has the actually favorable effect on the aquatic life. Density of water, what we said, that is maximum at 4 degrees Celsius. Actually, in the water at bottom of the lakes, it remains 4 degrees Celsius, even if suppose freezes at the top. It allows the fishes and the other marine animals to remain alive and move freely near the bottom of the water. If water did not have this property, the lakes and ponds also would freeze from the bottom and it would destroy even the entire aquatic life. So this will help the anomalous expansion of water of 4 degrees Celsius helps to maintain and give the aquatic favorable effect on their life. Specific heat. So the amount of heat which is required to raise the temperature of unit mass of substance through 1 degree. That we can say that the specific heat. So it depends on the nature of the substance and its temperature. So if an amount of heat del Q, it's need to raise the temperature of mass M, then the substance through del T, then the specific heat C, which is equal to del Q by M into del T. So the SI unit of specific heat that is, we can say that joule, kilogram power minus 1 and Kelvin power minus 1. Here the CGS unit calorie, gram power minus 1, Celsius power minus 1, right? So this is the SI and the CGS unit, and we can say that from this clearly, the amount of heat which is required to raise the temperature of mass M of the substance through del T is del Q. So del Q, which is equal to MC del T, right? Yes, students. So far we have learned from this session about the graphical representation of the thermal explanation of the thermal expansion, practical application of the thermal expansion and specific heat. Thank you, students.